We have Jordan Noone, who's my co-founder at Embedded Ventures, and Jessie Frazelle, who's one of Embedded senior advisors and the co-founder and chief product officer of Oxide Computer Company, back with us today as they teach me and all of you how to build an 8-bit computer on breadboards from scratch. So, Jordan, are you here? Jess, are you here? I think that they are still joining. All good. So, if you can see over here in the smaller window, and I'll actually flip it here so that y'all can see. This is kind of the progress that we made on Tuesday. So once Jordan's audio is on here, I'll have him kind of get everyone caught up. Britt, thank you, Britt. Britt has just popped into the chat the link so that you can get everything that you need. If you're wanting the parts list, if you're wanting the instructions, if you're wanting to know how to get in touch with us through our Discord channel, it all should be there.
I'm here too now. Can you hear me?
Yay! Yes. Hey, Jordan.
Hello. How's it going?
It's going. Your audio's cutting out just a little bit. Testing. 1, 2.
Okay. Let me try some stuff.
Okay. All good. Anyway, I would love to tell y'all while Jordan's correcting his audio, why we like to do this live on Twitch. We really want our viewers to see the learning process live. I mentioned this on Tuesday's stream, but learning is super messy. We all make mistakes, and that's okay. That's, one of the beautiful things about learning something new. Making mistakes, fixing them, and knowing the right way to do it for the next time is always important in a lesson learned. The stream also lets you, as the viewers, realize potentially your interest in STEM while interacting with me as I learn alongside all of you. So being live on Twitch also gives everyone around the world an opportunity to join along and learn this in real time, as I am as well. So let's talk a little bit more about STEM and how Jordan, Jess, and I all realized that this was a field we wanted to go into. I'll start maybe, and this will resonate potentially with some of you. I grew up, with, dreams of being a backup dancer for Beyonce. Never imagined I would end up in STEM. And, I also was, though, a tinkerer as a kid, and was always learning new things, but only kind of saw myself fitting into a box of where, my attention was going at the time, and nothing else. And a lot of that was because I never saw anyone like me doing STEM projects or anything like that. And so we do think it's important that everyone has the opportunity to see someone like them represented in a field. And so perhaps there's someone like me who's, has a cardboard cutout of Beyonce in their room, but also, loves tech and learning and building things in this field and might be inspired to pursue a career in STEM. So, Jordan, are you here?
I'm here. So.
Oh, Jess, yay! Awesome. Okay, Jess, Jordan's just correcting his audio really quick.
Nice.
But welcome, Jess. I'm so excited,
Okay,
Jess.
can you guys hear me? Sorry, I've been having a couple of things on my end.
Yeah, it's still a little bit off, but I think it'll work. Say something else?
Hold on, I'm gonna swap my headset.
Okay, sounds good. Jess, can you talk everyone through where we got to in the project, kind of an overview of what we did on Tuesday, so that anyone who's just now joining can get caught up? And I'll do my best Vanna White.
So on Tuesday, we set up the first 555 timer, and so we have a 1K resistor. We've got 2 capacitors. One of them is the one that's black, and then we have that orange little ceramic capacitor on the right. The orange ceramic capacitor, fun fact, you don't actually technically need this to get the 555 timer to work, but if you want to denoise it, then that's what you're using that for. And then the other capacitor and the resistor are helping with timing. So kind of what we're going to continue to do today is set up a couple more 555 timers. And this is for our clock. So we're basically just getting the clock to time correctly, and also not like jitter or anything like that. So all the denoising prevents the jitters.
I love it.
Okay, I swapped my headset.
Oh,
I should be good to go again.
Jordan, your audio is so crisp and clean. I love it. It sounds really good.
Perfect. Well, we can hop into stuff. Sorry about that.
That's okay. And just so that everyone knows, make sure that you are that you have the link open. You can find the instructions and everything on the link that Britt has put in the chat. And so just make sure you also then go to the tab that says instructions, and then there's another link to the actual project instructions. And so what step, if someone's just now clicking open those instructions, what step are we on?
We're on step 1.2.10. I believe the last one we did was 1.2.9. We placed, and let's just double check. We finished it. It was placing a 1 microfarad capacitor between pin 2 and ground. Let's double check we had finished that one.
2 and ground, I believe we did. Is
Perfect.
that this bad boy right here?
That is.
All right.
Awesome.
Yeah.
So we can step right into 1.2.10.
Okay.
So Jenna, you have a couple bags of the components in front of you. One of those bags has what's called a potentiometer. It's this kind of blue block with the white, cylinder.
I love potentiometers. And again, if you are using the bin eaters kit, there is a little pamphlet in here, and you can see kind of all the parts listed here on the pages. So look for your potentiometer, which is down here. Boom. There it is.
Exactly.
Awesome. Jordan and Jess, what does a potentiometer do?
I'll let Jess take this one.
So the potentiometer basically acts as like a kind of changing resistor, in that like it will change the kind of timing of our like 555 timer, and you can make it like fast or slow, which is pretty cool.
Yeah. Okay.
Awesome. So go ahead and grab the potentiometer, and let's show the camera for all the students so that they can see it. So the potentiometer has 3 pins on it, and we're going to connect each of those 3 pins to a different location on the board.
Okay.
But what we want you to do is to place a potentiometer pretty close by to the 555 timer.
Okay.
As close as you can get, but have all 3 of those pins in different rows on the board.
And do you want to go as close as you can?
Let's go leave like 1 pin in between.
Okay. And does it matter which side of the board?
No.
Okay.
We'll hook up to whatever side you attach to.
How is this?
That is perfect. And just to show everyone, those pins are underneath those 3 black lines there.
Yeah.
So they know the orientation of how to place that.
I'll use this as a pointer. Oh. Bam, bam, and bam. It's a little off.
And just
Awesome.
that's looking really good. That's looking really good. So we have 2 wires actually to connect now, or one resistor and then a wire. So we're going to go to step 1.2.11.
Awesome.
And so Jenna, you'll have to find a 1,000 ohm resistor. That's the same kind of resistor that we used already on the board. So it's per the color code that we have in the back of the instructions, and or in the bin eater guide as well. Good point, Jenna. That
Awesome.
Looks like brown, black, red. Am I reading that right? Oh no, I'm looking at the wrong one. Brown, black, red. Exactly.
Awesome. Alrighty, let me find my resistors. And just to refresh everyone's memory from Tuesday, can you explain the role of a resistor?
Maybe Jess, do you want this one again? The component wizard.
So the resistor, actually probably the best way to explain this is with the potentiometer. And like, so instead of the potentiometer, we could actually have like a resistor there with a set value. But what the potentiometer does is it changes the value of the resistor. So depending on the value of your resistor, the timer is going to change the way it behaves. So all of this just leads to like affecting the amount of voltage that is running through basically your circuit.
Does that look like the right one?
Brown, black, red. That looks fantastic.
Awesome. And y'all, I'm using, this is the back of my tweezer case. I have tweezers that I use kind of for everything, and I have various colors. Because on my desk here, they get lost if they're the same color as my desk. All right, so we have the right resistor. We're going to connect pin 7 to potentiometer pin 2. Okay, and can y'all make sure everyone knows what potentiometer pin is what?
Yeah, so the middle one is the output signal, and then the outer two can be used for power and ground. So as you adjust the potentiometer, it changes the voltage from the full range between power and ground to some value intermediary to that, so in the middle. So this one, Jenna, potentiometer pin 2 is going to be the middle pin of 3.
And I'm actually wondering, because I can't actually see here from where I put it on the breadboard, which row those are actually landing. So I actually might put the potentiometer on the other side.
Okay.
Let's see. Yeah.
That's
that way
normal,
you can
yeah,
that way you can see which. All right. So so we are connecting pin 7 from the 555. And so y'all remember, we go 1, 2, 3, 4, 5, 6, 7. Let's see. Let me use my tweezers again. Jess, can you explain to everyone watching how you ended up in STEM?
So I've loved computers for a long time. I also just love like figuring out how things work. So taking things apart and then putting them back together, that's probably the best way to figure out how things work. I majored in math, and then I had to take some computer science courses as to get that degree. So I love the computer science stuff. Didn't want to become like a math professor or figure out theorems all day. So I decided to do computers.
I love it. And y'all, I'm actually choosing to put my potentiometer now actually remix on the other side. And part of that is because this resistor has to go from 7 to 2. And there's another resistor right here, and I don't want them to be touching. Is that cool?
That's totally cool. That's the normal kind of trialing as you put these together is, you try it one way and you're like, oh no, these components are going to interfere. And it's really hard to predict that stuff ahead of time.
Yep. And so why would I not want them to touch?
When they touch, that's shorting them. So it actually allows electricity to flow between the two, which would be a different circuit. You'd have electricity flowing in another way. So by making sure they don't touch, you make sure you stick to the original intended design.
Yeah, so then 2 would be here. And so now let me make sure these aren't touching. There we go. Does that look about right?
That looks about right. Awesome.
All right.
And now we'll get to the next step there, which will be 1.2.12.
Okay.
So you'll want to use a jumper again and connect the 555 timers pin 6 to potentiometer pin 1. And actually we're going to use one of the fun facts about the potentiometers here, that you can actually hook up to either of the other pins to do this. Which one is pin 1 and pin 1, which one's pin 3 doesn't actually matter right now.
Y'all,
So
I'm really not doing this in a beautifully aesthetically pleasing way with the jumpers here, so I apologize. Maybe in between streams we can rework it so that the colors match. But all good. Okay, so connect the 555 pin 6. So 1, 2, 3, 4, 5, 6 to pin 1. I think this should be about the right size. Sorry, y'all. I'm gonna bring this close to my face just for a second. 6. Okay, 6 would be like there. And then pin 1. I might have chosen one that's a bit too big. Let's see. Let me try to bend it. with the tweezers. These were already, the ones that come in this kit are kind of sized a little bit, and so there we go. How's that?
That's looking...
We got a little bit of a maze here. I'm gonna bring this closer so that I can make sure it's all the way in there. There. There we go. Does that look about right? Okay. 1, 2, 3, 4, 5, 6 to 1. How's that?
That looks good.
Y'all, and let us know in chat if y'all have any questions as you're watching. Yeah.
Awesome.
Sweet.
That's looking good to me.
I like it.
Okay, so that's actually the majority of that first clock. So now we're going to add, in step 1.3, the indicator LED light that'll show the timing of the clock.
Sweet.
So I recommend doing this in one of the corners of the board. So if you orient the board the other way, Jenna, back kind of horizontal rather than vertical.
That's right.
I can't see the whole thing.
And the LED is going to show us like really how the potentiometer works. It's going to be cool.
Yeah, so actually maybe flip it again to like 180. Do some escape tricks. Perfect. Perfect. And on the bottom right, we'll do this one.
Down here?
So what you'll want to find, right over here, we'll build out a little light circuit.
Okay.
So I recommend you find a blue LED.
Alrighty.
So a bag of blue LEDs that came in the kit.
Y'all. That's hilarious. I'm like, how do I get this out? Where are the scissors? Oh, there they are. There we go. Y'all, I'm still drinking my Starbucks. My go-to. It's a iced caramel macchiato. Not sponsored, but actually, it's so good, y'all. Jess, what's your Starbucks order?
I really like the caramel macchiato, honestly. I also like, if it's like a rough day, a red eye. It's like
what's that?
Coffee with a shot of espresso.
Ooh! Oh gosh!
A black eye, which is 2 shots of espresso.
What? Oh my goodness, I would never sleep again.
Yeah, those are like a heart attack in a bottle. Basically.
Oh my goodness. Okay, so here's a blue LED. I'm gonna show it to y'all on the back of my tweezer case again. This actually kind of works. How's that?
That looks good.
Hey, LED. All right, where
and the
are we
LEDs have, they have 2 legs, one of which is longer than the other.
Yep.
The longer leg is the positive leg.
And that's
so
because positivity takes you further.
That's right. That's right. And we're going to place that into its own column in the right, somewhere in the right. So go ahead and place the long leg kind of somewhere in the corner there, but in one of its own columns, like column 1 or 2. You can see their numbers.
Okay. And that's the longer leg?
That's correct.
Okay, how about here?
Putting the long leg in a column, is that column 1?
Yep.
Okay, and then go ahead and place the shorter leg, and this is step 1.3.1.2, we're really detailed, into a nearby column. So let's say column 2.
Oh, okay.
Just kind of have it straddle the two different columns there.
Okay, actually I'm gonna have to take it out to do both of those. There we go. How's that?
That looks great. So we're going to now place a resistor. The reason you add a resistor with the LEDs is to make sure that the right amount of voltage goes to the LED, and then some of it goes to the resistor. And if you don't, you can fry the LED, like frying a light bulb. So Jenna will need you to find a 220 ohm resistor.
Okay.
And we can reference either the Ben Eater pamphlet or...
We are cheating a little bit with this pamphlet, I feel like.
That'll be red, brown.
Yep.
So you'll want to find those.
And y'all, on the instructions doc, if you scroll all the way to the bottom, there is a resistor color code chart. Actually, why don't we find it using the color code chart, just so that everyone really understands how to use the chart to find out which one. Jess and Jordan, Jonah, walk through that.
Yeah, so on the chart, if you see, red is 2 for the first band, and then it's 2 for the second band, and then the multiplier column, we'll look at the brown one is 10. So if you multiply all these things together, then you'll actually get 220.
Yeah.
Awesome.
Okay, so I believe, and that's red, brown. How's that look?
It's a little hard to tell. Let me go a little. Oh, that looks great.
All right.
Great.
Red, brown.
For our next project, we can get you a potentiometer, and then you can actually check with the potentiometer on, not the potentiometer, or multimeter.
I love it. Also, I love Britt just mentioned the teachers at Robeson County Schools who have made this happen. Miss Robin Johnson from Littlefield Middle School, Miss Phyllis King from Lumberton Junior High School, Mr. Jessie Bullard from Pembroke Middle School. And y'all, my mom did correct me. She was like, I wasn't born and raised in Fayetteville. I was born in Albuquerque, New Mexico, and then raised in Fayetteville. But she was the fact checker of the Tuesday stream. And she also really wanted me to ask everyone here, what is the accurate pronunciation for Robeson County? So she said that locals call it Robeson County. So she said if I want to sound like a local, I should say Robeson County. But apparently it might be meant to be Robeson. I don't know. So y'all let me know. Maybe if any of the teachers over there, if y'all have your audio on in the Zoom and want to unmute yourself really quickly to make sure we know how to say it. Or make sure my mom knows which one we're gonna go with.
Well, we can jump back in while we wait for that. But we're gonna take that 220 ohm resistor,
awesome,
and we're gonna place it between the short leg and ground.
Short leg and ground.
Short leg of the LED, which I believe is on the left.
Yeah, it is. So we're gonna go here. And then ground is negative, so this other leg we're gonna put over here. How's that?
That's looking good.
Awesome. I'm gonna
So
switch the view back.
Awesome. That was step 1.3.1.3. And now the next step here, we're going to connect pin 3 of the 555 timer all the way to the long leg of the LED.
Pin 3 of the 555, which is way over here.
Yeah.
And let me do a far out view just so y'all can see what all we have going on here. I'll actually slide this over here so you can see the 555 timer is over here. And then we're going to be coming all the way over here. All right. While I'm engineering that up, Jordan, why don't you tell everyone how you ended up in STEM?
Oh, I don't have a great story there at all. Really, I think I like doing math and physics in college or in high school. Sorry, and then engineering made sense to apply to for college, and I did. And it worked out really well, to be honest. I joke that I winged it into aerospace. But no, that was a lot of it. I just enjoyed, similar to Jess, I really enjoyed tinkering with things and playing with hardware and building different things and, playing with Legos. And that naturally led to where I'm at now.
Oh, speaking of, we have been trying to think of what hashtag we should use for this stream. So y'all, let us know if you have any ideas. We were throwing around some ideas yesterday that were like built on Twitch or what were some of the other ones, Jordan?
Built on Twitch. Oh gosh, I'm trying to remember all of them.
And y'all,
and Jenna,
I don't think this jumper is long enough. So I might have to move my LED and resistor over.
Well, Jen, I actually recommend on this one, the line you're adding in right now is just temporary to test the circuit, and then you're actually going to remove this.
I know, but y'all, it's not long enough.
So you can use 2 jumpers. You can kind of bridge them somewhere in the middle and use 2 half-length ones.
Alrighty. Why don't you talk everyone through that?
Yeah, so go ahead and grab a shorter jumper.
Okay.
And just place it between pin 3 and somewhere kind of halfway through one of those columns.
Alrighty. So that's going to be 1, 2, 3. Okay.
And then just place it anywhere in between on any of those columns.
Okay. How's that?
Perfect. And then grab a similar length one and have that go between where you just placed, the second end of that jumper and the LED.
All right.
And we can do that because all of those columns are connected, so we can just use that to basically as an extension cord. Almost.
Okay. And so where exactly is this one gonna go?
Go from that same column.
Yep.
Is that? I think
right
it's
here?
like column 36, exactly.
Okay. Okay.
And you'll want to take that all the way to the long leg of the LED that you had placed.
And the long leg was the right side, I believe.
Yes.
Okay. And this is temporary, so I'm just gonna go wherever's the most convenient. Oh, how's that? It's not very pretty, but
no worries. That's perfect. That's perfect. We're just gonna do a quick test of that part of the circuit that you've built to make sure that it's running correctly. And then we'll be changing that later.
Alrighty.
So now that you've placed that jumper in, which was step 1.3.1.4, we're going to go and add a couple capacitors as power stabilizers. Jess was talking at the beginning that you can use capacitors for a variety of reasons. We're going to jump to step 1.4.1, and you're going to need 2 0.1 microfarad capacitors. So Jen, you can actually check the handbook to confirm what those capacitors look like. So there's a variety of different capacitors that are hard to tell apart. So we want the 0.1s, which are those orange ones that say 104 on them.
alrighty.
You'll want to grab 2 of those. Should be a bag of those in the kit.
Okay. There's 103. Here's 104.
Perfect.
Awesome.
And you have 2?
Yes, let me just get this bag open. Sweet. And Jordan, maybe tell everyone about how you had the idea originally to stream while learning new things or engineering things.
Oh, yeah. No, one of the things that I really wanted people to see was what the process was like to learn. It was something where, doing engineering, doing any project, you spend a lot of the time just, Google searching on specific details. And a lot of people think you have to memorize everything, know how to do it before you hop into it. And that's not how, the real world works. You give it a shot and you learn. And that's something I wanted more people to witness and more people to see. And that eventually led to where we are now with Jenna going through these projects live as an opportunity to show that anyone can learn, anything if they just put the time into it and put that preparation in. And we want to be able to do that with you guys.
Yeah. And also, y'all, my mama was right. It is Robeson. Okay, I'm gonna stick with that. I wanna say it the way the locals say it. Robeson County.
Awesome.
I love it.
Awesome. Well, let's place those capacitors in. We're going to place them between power and ground. So it'll be pretty simple, maybe just in the top right corner of where you were working, Jenna.
Okay.
And so what's, I guess, in the top left corner in the current view, it's rotated here. But just between power and ground in the corner.
You said going up here?
Yeah.
Okay.
It's power and ground, and those will be connected to stabilize the power coming in. So that's why they're connected
so
there. Just power, exactly. Perfect.
Right.
And just place them both next to each other there.
Sounds good.
Those will just smoothen the power coming in.
How's that?
Perfect. That looks good. Okay, and now we're going to work through the rest of the power to the board. So we're going to go to step 1.5.1. That is connecting the power row on the top of the board to the power row on the bottom of the board.
Yes.
So you know how there's that positive row on the top and positive on the bottom. You'll want to connect those two with a jumper to make sure the whole board gets powered up.
I'm just going to acknowledge in chat, yes, I agree. All of the best stuff I learned was from making mistakes. Same. Okay, great. Sorry, one more time, Jordan.
Yeah, so you're
and actually, Jordan, if you can highlight, because if anyone's looking on at this document, if you just highlight the step that we're on, everyone will be able to see it. Perfect.
Perfect. Just
connect
do
the
that.
power row on top of the board to the power row on the bottom board using the jumper. Great.
Positive to positive.
I'm really wanting these to be like the perfect length. So this is beautifully done, but I just don't. Ooh, this one might actually work. Okay. Does it matter where?
Slide it under.
Yeah.
Try to keep it compact, maybe close to where your LEDs and your capacitors are.
Okay.
Because we're going to use the. Yeah, try to get as close as you can, because there's going to be a lot of the rest of the board used for the rest of the clock circuits.
Okay.
And that's again on one of those things on learning. So, the first time I tried putting one of these together, I ran out of room because I did not, and I had to rebuild the whole thing.
How's that?
Because I was too spread apart. Let's look positive to positive. That looks awesome. And now we're going to do the same as the next step. I'll highlight it here of 1.5.2, which is doing the same thing but with ground.
Okay.
Negative. So negative to negative, that same spot or very close by.
Alrighty. I can do that. Yeah. What are y'all what are y'all schedules looking like today, Jess and Jordan? What are y'all up to?
Some phone calls, some work, prepping for next week's stream.
Yeah.
Making sure that's good. We're office hunting as a fund right now,
Yay.
so that's in work. A lot of fun stuff. Perfect. Nailed it, Jenna.
How's that?
Good.
Nice.
Yeah.
That's a good. So now there's a step. There's
Thanks,
Thanks, Britt. There's a. We'll jump into the next step here of 1.5.3.
Okay.
If you're ready for that, Jenna, you'll need to find, there's a power adapter. So if you actually look in the Ben Eater manual, maybe pull that up so that everyone can see what we're looking at. And it's that power plug adapter there. If you could find that in your kit, it should be in one of the bags.
Here it is.
Perfect. And let's show everyone. Perfect. And you'll want to attach, and it looks like I may have not actually removed them from when I was playing with it earlier. There's two jumpers that you'll want to install. So if you flip it over, Jenna, you'll actually see the screws. There's two screws on the other side of that adapter. Let's show the group. And that's how those jumpers are attached in. So you'll want to use... Perfect. You'll want to use a screwdriver to attach those, but Jenna, yours are already attached.
Should I attach them so that should I redo this?
Maybe show the group. Yeah, show the group. There's a little screwdriver that everyone should have as well. To use that to very gently. You don't need a lot of force with any of these. With a little Phillips screwdriver, you can take out those jumpers and add them back in.
Here are the. Can I see that? There we go.
Perfect.
Okay.
Yeah, so go ahead and maybe remove one of them and then add it back.
Okay. Let's see here.
You shouldn't have to loosen it too much. They're kind of spring-loaded, so you should be able to just hop those out. And again, be gentle with them. They're very, very delicate screws.
There we go.
Awesome.
And now just throw them back in?
Yeah, throw them back in.
Okay. And how do you know exactly where you're putting it back in?
You go ahead and just slide the jumper cable into there and then tighten the clamp down onto it.
Okay. Here we go. Alrighty. Are y'all having fun? I know that the students are doing this at the same time, but I'm curious if anyone here on Twitch, if y'all have gotten the kit and are building this with us, please let us know.
Perfect. I know Jess has been building one in parallel too.
Yeah.
Yeah, it's super fun.
There we go. How's that?
Awesome. That looks great. So now we're going to plug that into the board.
Okay.
I recommend doing this if you orient the board back to how it was in the top left corner. And just for everyone on the instructions following along, we're at step, I lost my spot. Where was I? We just connected the two jumpers in step 1.5.3 to the power adapter. And now we're going to attach those two jumpers to the board. So I recommend in the top left, if you check the power adapter, one of those two cables has a positive indicator next to it on the green, and the other one has a negative, the actual adapter.
Okay.
You just jumper to one of those. Yeah, check to see if, I think you have a gray cable and a white cable there. When they plug in, there should be a positive label and a negative label on the plastic of that adapter. Show everyone positive. So it looks like is that white is positive and gray is negative.
Y'all, is this not a grasshopper? Is it just me, or is this a grasshopper? Wait, can you see that? That's a grasshopper.
It's a little, yeah. So you see those? It's indented in the plastic there, but that's perfect right there. So white is positive, and then gray is negative.
James Freeman, how are you? From ETI in Robeson County. James, thank you for all of your help. James saved the day and made sure, I believe the kits were delivered to the schools on a weekend, and we were like, oh no. And James saved the day, made sure that the school got them. And also, like, we're just so excited to learn more about everything that he's doing over there as well. So thank you, James. And thanks for joining the stream. I love this. Let's go. I'm pumped too. I love it. James, we need to make sure you have a kit. Britt, Hannah, we need to send James a kit if he doesn't have one. There we go. Now you can really clearly see the positive and negative. There
awesome. And we only have a couple minutes, so let's try. We have one or two more steps I'd like to get through today. So let's plug those positive and negative terminals into anywhere on those positive and negative rows on the board. Okay,
and do you typically, if we're going to choose our dream spot,
maybe the top right, like above where the potentiometer is, will actually be, top left. I misspoke there. Top left above the potentiometer.
And we're going positive to positive, negative to negative?
Yes.
Okay. Yes, James, teamwork makes the dream work. That's right. 100%. So let's see, positive to positive. Does it matter? Like, can it be right here?
It can be on any of them.
Okay, let's do this. This is totally, to me, this is a grasshopper. That looks just like
awesome.
Here we go.
Maybe kind of angle it off the board, just so.
How's that?
Perfect. That's perfect there. Awesome. So that's connected, and now we're actually going to hook the board up to power. Now, so Jenna, you should have a power cable already plugged in. For everyone watching, you'll have to plug that in as well.
Yep.
But in the kit, in a white box, there is a power cable that plugs into a standard outlet. That's going to convert the wall voltage, which is 110 volts, to the voltage needed for this project, which is 5 volts. And that's going to plug right into that adapter that we've been playing with.
Okay.
So Jenna, if you could.
Just out of curiosity, what do we expect to happen when we plug this in?
We expect the LED to start blinking.
Alrighty.
So we're going to plug it in, and then don't touch any of the electronics because everything's plugged in at that point.
Let me get organized here. And I'm going to switch the view so that y'all can see all of this happening. Let's see. Let's go to this far view, but I might lower it just a little bit.
And this is the final minute, so this is the true test of what we've built.
And y'all, this is an exciting, anytime it's, we're expecting something like this to happen, it's exciting. So here we go. All right, that's a decent view, right?
Yeah, that's good.
Okay. Here we go. So we're basically just going to be connecting this.
Yeah.
All right. Who wants to count us down?
3,
Jess, Jordan?
2, 1.
Yay!
That's awesome. So you see your LED lights blinking. This is very similar to Jenna's original 555 timer controlled LED light, but the really unique thing today is that we have the potentiometer.
So turn the knob.
Oh, yay! Okay.
The potentiometer.
And actually, y'all, you might need. Actually, I'm just gonna use my tweezers because sometimes these nails, y'all, get in the way. Here we go.
Yeah, they're really hard to turn. Actually, I took off a layer of my skin doing it.
Oh my gosh, Jess!
I mean, it was minor, but yeah.
There we go.
Everyone can see, and this is awesome. Jenna nailed building this circuit. There's a big celebration going on in chat too.
Thanks, y'all.
Right now.
Thank you for teaching me. In Robeson County, how'd it go? Do y'all have blinking LEDs?
Yeah, and just to add a little bit of detail to this, we're right at time, so we're going to have to stop fairly soon. That signal that is coming out of the clock is the signal that will control the timing of the computer. So you can actually turn that potentiometer to either slow down or speed up the computation within the computer.
I love it.
Which is really exciting. And we're going next to be, and next week, building another clock next to the one Jenna has added in that we actually control manually. So rather than it being, automatically timed, you'll be able to click a button and it'll cycle the clock, one step at a time. So we'll be starting that on Tuesday.
This is so cool. Thank y'all so much.
Awesome. And to stop everything, just go ahead and unplug that circuit the plug from the adapter, Jenna. And then we'll start up next week by removing the little test wires you've added in and then building that next clock alongside it.
Awesome, y'all. Thank you so much for teaching me how to do this, Jess and Jordan. Thank you, everyone who's watching, and everyone at Robeson County. We're so excited to be building this with y'all and alongside the Mentor Project. Yes, thank you, Britt and Hannah have been awesome at keeping the chat engaged and making sure that y'all have all of our social media links and everything. Join our Discord channel, and if you have any questions as we're building this together over the next now 5 weeks, please send us a note on Discord, and we would love to answer those as you are engineering this at home. Perhaps you're not live with us here today. Just feel free to send questions there, and we'll try to answer them while you're doing it live. So thank y'all so much, and we'll see you next week.